Welcome back to another video in this computer organization course, and welcome back to my channel, everybody. So today we'll be focusing on binary to hexadecimal. So converting from the binary system from bits into the numbering system of 16. Alright, so how do we convert from binary to hexadecimal? But before we get there, I just want to do a little review. So, if you guys remember, hexadecimal has a radix of 16. So it goes from 0 to 9, A to F. And A corresponds to 10. So A equals 10. All the way to F equals 15. So how do we convert? If you have not seen the binary to octal video, it's very, very similar. So what is 16 in base of 2? 16 in base of 2, what is that? So that's 2 to the 4 equals 16. So we want to use 4-bit places. So how do we do this example? 1, 0, 1, 0, 0, 1. So what we want to do is we want to get 4 bits, and then for the other ones we want to get 4 bits. And we can just fill the rest of these with zeros. So we're going to separate these 0, 0, 1, 0, and 1, 0, 0, 1. So we want to have the correct placeholders for it with the correct powers of 2, I mean. We're going to do the same thing with the other one. Alright. And we want to match up which one digit we have, which value of 1 we have in the correct placeholder. Alright. So for this left side, we only have one value of 1, and that corresponds to the power of 2 to the 1. So it's going to be 2 to the 1. And on this side, we have 2 places that correspond to the value of 1. We're going to have 2 to the 3, and we are going to have 2 to the 0. So what are those values? 2 to the 1 is 2, and on the right side, 2 to the 3 is 8, plus 2 to the 0, which is 1, equals 9. So in binary form, 101001 in base 2 is 29. Is 29 in base 16. So that's how we figure that. It looks exactly the same as the octal form. So we'll do this one more time. 1, 1, 1, 0, 1, 0. So what we want to do is we want to start from the least significant digit to the most significant digit to separate into 4 bits. So we want to start off with this 0 all the way to this 1. Then we're going to start with the next one from this all the way to the next 4. We're just going to add 2 zeros in there just to show that we are showing 4 bits. So what's the difference here? We go from 2 to the 3 all the way to 2 to the 0. Here, this place corresponds to the 2 to the 1 place. And this place right here corresponds to 2 to the 3 place. And this one, 2 to the 0, 2 to the 1, 2 to the 2, and 2 to the 3. This place right here corresponds to 2 to the 1. And this place corresponds to 2 to the 0. And if you remember, these are like separated. So what do we want to do? We want to add the 1s. So it's 2 to the 1 plus 2 to the 0. And over here, we have 2 to the 3 plus 2 to the 1. So what we're looking at right here, we're looking at 2 plus 1. So this value is 3 over here. And over here, we have 8 plus 2. So this value is 10. And then remember, in hex format, A equals 10. So this value over here will be A. So 111010 in base 2 is 3A in hexadecimal format. Going on to the next one, very similar. 0 1 get the 4 digits. Over here, same thing, get 4 digits. Add those two zeros. So this is 220, and this is 221. Remember, it begins anew at every single one. So it's very important to add those 2 zeros at the end, because you want to make sure that it looks proper and that you're noticing that you have 4 digits. And at the same time, you want to start finding your 4 digits from the right hand side going to the left hand side, because let's say I decided to start reading this way, right? And I decided reading this way. This value is completely different than me reading from this side. So you can see these values right here is completely different to this value right here. So you want to make sure you start reading from the origin point and this way, not from the highest digit reading this way. So before I got off on that side tangent, let's figure out what's the answer. So 2 plus 1 and a 1. So what we're looking at is 31 in hexadecimal format for 100001 in base 2. Another one, it's going to be the same exact thing. So what we're going to do is we're going to have this 1100. We're going to add an extra bit right here just so we can have our 4 digits. Same thing here. Oop. So we're going to add an extra 0 to the end so we can have our 4 digits. So 2 to the 1 and 2 to the 2. Over here, the same thing, 2 to the 0 all the way to 2 to the 3. The only one that has a 1 is the 2 to the 1 place. So we're going to add these up. It's going to be 6.1. 6.2. So 110.001 in base of 2 is 6.2 in decimal format, hexadecimal format. Same thing, 110. We just add this, tack on this extra 0 right there. 101. We tack on this extra 0. Now let's do that. So here's 2 to the 1, here's 2 to the 3, here's 2 to the 1, here's 2 to the 2. These correspond to the places with the 1s. And then we're going to add those. So it's going to be 4 plus 2, decimal, 8 plus 2. So this is going to be 10. It's going to be 6. What we're looking at is 6A. Remember, A equals 10. So what we're looking at is 110.101 equals 6.A in hexadecimal format. And for the last one, just like before in the previous video, this is going to be a little bit more extensive. So let's figure this out. 410101.11001. All right, let's get our 4 digits. 4 digits and 4 digits. Tack on these extra these extra digits right here. 4 digits, 4 digits. Tack on these extra digits to make it 4 digits. So what are we looking at? We're looking at 2 to the 0 for this one and 2 to the 3. For this one, we are looking at 2 to the 3 plus 2 to the 2 plus 2 to the 1. And for this one, we're looking at 2 to the 0. This one, 2 to the 3 plus 2 to the 2. This one, 2 to the 3. And this one, 2 to the 3. So what are these values? 1. Here, what we're looking at is 8 plus 4 plus 2. So 8 plus 4 plus 2. What we're looking at is the value of 14. And the value of 14 equals E. So here we're looking at E. This one is 8 plus 1. We're looking at 9. 8 plus 4. The value of 12. A equals 10. B equals 11. C equals 12. D equals 13. E equals 14. And F equals 15. So here, the value of 12 is going to be C. Remember, we have a decimal place over here. 8 and 8. So 1, 1, 1, 1, 0, 1, 0, 0, 1. Decimal 1, 1, 0, 0, 1, 0, 0, 0, 1. In base 2 is 1 E 9 decimal C 8 8. And there you are. So that concludes our binary to hexadecimal video. So if you guys did enjoy the video or you found some use in it, please leave a like, comment, and subscribe for some more educational and computer organization videos. And if there is a topic that you guys want to talk about, please leave a comment so I can get started on that. Thank you guys and have a nice day.